Hello students, thanks for your questions on the LE forum. I can't stress that enough. Please use it because it's important for our feedback. The Education Endowment Foundation show that effective feedback is the most efficient way of improving learning gains in a course. And that feedback isn't just me providing you with feedback at the end of the course or your end of your assessment, but actually it's you providing me with feedback in terms of what you're understanding, what you're not understanding, and then me responding to that of my own feedback. So it's a two-way process, feedback from you, feedback from me, and we'll keep going. So I've had some feedback from you guys in terms of I'm not really sure what I'm looking at in the practical. Let's go through it then. Apologies if that's the case. Steve and I, we spent a decade each looking at parts of the green and ice sheet. So we should probably have maybe assumed too much. But you'll load the mask initially, and you'll see that with visible layers in the information button, the green and ice sheet is 2, the land is 1, and the sea is 0. Now, if that doesn't make sense to you what you're looking at, then I've uploaded a shapefile, the green and ice sheet country boundary. And at this point, it's fundamental to say that with GIS, your drawing order is your display order. So if I move this below that layer, this one is now being drawn on top. So let's zoom to layer, and you'll see the context of where we are in location of the green and ice sheet. And if we zoom in to the coast, you'll see that mask makes sense now. You can see there's the land, there's the sea. Hopefully then you know what you're doing, and you can add in your first layer, which is the elevation layer. And we're going from low elevation, high elevation, so high elevation in the interior of the ice sheet to low elevation and sometimes below sea level. Hopefully that makes sense. Let's then add in some velocity data that might look like this. We can, probably the first thing you want to do actually is just get rid of some of that background value, no color. If we apply that, there we go. So now we can only see data where we have values rather than no data. And you can see Jakob Sava and Isbray really pings out. We can change the color here so that we can see it. I think divergent color scale, maybe 2 colors here is appropriate. Don't need to invert that. Let's have a look. Nice. Okay, so we're still looking at that on top of the elevation map. I'm going to go ahead and turn that off for now. Don't really want to see it on top of the mask. Oh yeah, so this is the point in the practical where I said we're comparing it to the Jochen paper, figure 6, and the background imagery here is a SAR image. So I thought, oh, let's give you a SAR image so you can see what you're looking at. But that's caused some confusion, so sorry about that. Let's have a look at these 2 SAR images. We've got one here for the west coast and one for the south. They're in these strips because these are the tracks that the satellite go down, and these are large footprint images, really nice for like the background kind of image that we're using them for here. So it's SAR is synthetic aperture radar, and that is a active system in the sense that the radar is sent from the satellite to the surface of the green ice sheet. It pings back, and then the sensor measures how much radar is received. Now, for areas like closer to the interior, where you have lots of snow, fresh snow, lots of volume scattering, so that radar can penetrate into the snow, ping off all these ice crystals, and then gets sent back to the sensor. And so that's why we're having really high backscatter values towards the interior. Where you have dark values, you'll have really low backscatter. That could be absorption due to water, or it could be more of a sort of mirror reflection away from the sensor, where you have like exposed bare ice. It really does add in that layer of complexity, but allows you to also identify different ice facies on the surface. So yeah, really nice data, worth having a look at. What I've done again is I've gone ahead and ticked that box. The background value is not being drawn. You don't want to see all the area around the scene. So we've got our SAR backscatter, we've got our velocity data. Looks nice, and we're trying to reproduce this figure from the Jochen paper over here. Okay, so actually one thing that isn't in the handout, which you anticipate you might ask me, it's the first time I've run this assessment, is this logarithmic scale. Alright, first off, do not, I know we want to reproduce this figure, but do not use this colour scale. Oh, it's disgusting. Mostly, the worst thing about it is it's circular. So you have red for low values and red for high values. There's no way of differentiating them. So if you did that, if you chose that colour bar, I don't know, if we got one here similar. Yeah, something like this. Oh, it's just gross. Look, you've got low values in red and high values in red. Don't use that. Please don't use that. If you really, really wanted to use a rainbow, go with this. It looks pretty, doesn't it? But it is introducing these false steps. Look where they have that really bright yellow. So my suggestion would be something like this: the two color differentiated color bar. We don't need to invert that one. But this is a log scale, so you might ask me, okay, how do I apply a log? Well, you can do that using our friend, the Raster Calculator. Let's make this full screen whilst we're doing this. Yeah, Raster Calculator. Go ahead and go Windows search Raster Calculator, and we can use this natural log here. Add in the velocity data. We'll just call it, for the sake of this demo, something like V 2017-18 natural log. Hit OK. The idea of this is it allows you to show clearer the velocity differences across the surface. It kind of stretches out the values across that log. If you don't know what I mean by log numbers, look that up in Google. So let's go ahead and change that color bar to that one there. And we can look, what I'm going to do is flick this on and off so we can just make the comparison. So we've lost a little bit of that detail in terms of the Jakobshaven tongue, but we've gained detail elsewhere. Actually, first of all I need to tick that display background value. Don't display the background value. So again, if we go back to our paper, you'll see for the same area, I'm just going to put this on the right side of my screen, put this on the left side of my screen. I just used the Windows and arrow button to do that. Then where are we? Jakobshaven display. Yeah, there's this island here. So we're a bit too zoomed in. That's a bit more similar to what we're looking at over here. So with the natural log, oops, I've just put that into a group. Didn't want to do it. With the natural log, you can start to see some of the textures that Jochen was showing in his paper. This texture, not texture, that's not a very good word, is it? Structure, flow structures, which is more what we're looking at here. So yeah, it might be a really good way to show that data. To label it up, similar to that legend, you can go to labeling. Number of intervals, well, we've got 1, 2, 3, 4, 5, 6. Generate, and then I've got 7 there now. 5 intervals to generate 6 labels. and you can go ahead and change that. And it makes sense just to have the actual numbers on there rather than the logarithmic numbers, as Joachim has done for his paper, and so on and so forth. Oh, rather than, obviously, don't just change these labels to coincide with this. I think what it's done is it's split that into 6 different figures. So you take your value and do the exponential of that. That's quite straightforward to do. You can just Google EXP, exponent, and just take those values. Whoops. So, actually, I've got this the wrong way around, haven't I? Yeah, if I do EXP minus 3.137, give us a value there of 0.04. So in the Joachim paper, it was saying less than 1. So let's go ahead and just go less than 1. Up here, 9.3. We can go ahead and do XP 9.3, and that's taking us to 10,900, so maybe more than 10,000 would be good. For example, and you do the same for the rest of them. So that's 10,938. Let's apply that. Just check that makes sense. Yeah, over here. Yeah, that makes sense. We're looking at 12,000. Oh, that's 2005. Yeah, there you go. 10,953. Okay, perfect. Yeah, so go ahead and change those in between, and you have a nice looking figure. It's more similar to this one, and bingo, we've done that velocity map very nicely. With the difference, let's talk about the colour scale there. Again, I've gone on tick that. Oh, I haven't ticked that. It's no colour apply. I don't think that matters actually, because we've applied and masked this data. And I've gone divergent colour scale between red and green, which again isn't great if you're colourblind. You really might struggle, but let's stick with it because this is what they're introducing here. Unless there's a, yeah, I'll let you play around with the colour scale. But to change the way this is labelled, you want to go into minimum, maximum, edit the values, and you edit the values here, and it will automatically update the label there for you, and that will be then consistent with the paper. And again, because this is differencing now, you don't need to worry about a log. You can see the really nice flow structures, especially for Jakobshaven. Yeah, and up here, really nicely and really clearly, and you can hopefully see some of those patterns forming. But let's just run you through now the rest of the data, just so that you know what you're looking at. I had questions saying, "Oh, why can't I just see this random square, which is here, down here in the study area?" Well, that random square is the SETSM data, and it's just much smaller. So we can go ahead and zoom to that layer. Much higher resolution data. Zoom in, and you'll see some of the features really clearly here. Beautiful. Okay, you can check that by just looking at the resolution of the image, properties, and go to source, and you can see that it's yeah, there you go, 5 meters compared to the rest of the data. So I hope this is really helpful, and you now have a much better oversight as to what you're looking at. Thanks very much, and I look forward to seeing you in the practicals.